5%. Okay. Moving on, identifying divisors. Circle the pairs, simplify and write the principal root. Okay, so here you have square root of 2 over 2 times 2 times 2. Okay, so square root of, you literally have square root of 2 times 2 times 2, which will be square root of 8, or you can write this as square root of 4 times 2. Okay, you can write this as square root of 4 times square root of 2. Square root of 4 we know is 2. Square root of 2 remains square root of 2. So that's how they got 2 square root of 2. Okay. Then you have square root of 16, and that's written as square root of 2 times 2 times 2 times 2, which is square root of 4 times square root of 4, which is 2 times 2, which is 4. Okay. Then you have 32, which is again 5 2's. So 2 times 2 times 2 times 2 times 2. So let's circle the pair. Square root of 2 squared is 2 dot square root of 2 squared is 2 dot square root of 2. Okay, that's 4 square root of 2. Okay, that's what they've gotten there. Okay, let's do 64 now. So then that becomes 6 2. So this is a pair, this is a pair, and this is a pair. So 2 times 2 times 2, which is 8. Okay, this is a pair here, so that comes out of the square and it becomes a root and it becomes 3, and then you have 3 square root of 3. Okay, 81, you have 2 sets of, or 2 pairs of 3. So 3 times 3 will give you 9. Okay, complete the factor patterns. Okay, before we get into this, I just want to quickly want you to look at the charts. Okay, because there's a little bit of information about factorization which I don't want you to miss. So here, when you're talking about divisibility, you know, we already looked at this, the table here, right? The forms of division, complex division, polynomial division, and we didn't see polynomial division, but we looked at decimal fraction, obelisks, and all this. Okay, we also looked at if they have a common denominator, you can add the fractions, you can add the numerators, right? Then we talked about LCM briefly in the previous booklet. We're going to talk about LCD here, but before that, let's look at this. So you have some divisibility rules here. So if the last digit of a number ends in 0, 2, 4, 6, or 8, okay, for example 3, 9, 6, 8, if the last digit is an even number, you can divide it by 2. Okay, if you have a number like this, and if you add those numbers, like 3 plus 1 is 4, 4 plus 5 is 9, then if 9 is a multiple of 3, then you can divide it by 3. Okay, these are some shortcuts. If the last 2 digits are a number which is divisible by 4, so the last 2 digits here are 12. Is it a number which can be divided by 4? Yes. So then that number can be divided by 4 evenly. Okay, the last digit is 0 or 5, it can be divided by 5. Okay, if this digit is 0 or 5, it's a number which is divisible by 5. If the number is divisible by both 2 and 3, so here you have 348. This number is divisible by both 2 and 3. If you divide this by 2, you get an answer. If you divide this by 3, also you get an even answer. Then the number is divisible by 6. Then here the last 3 digits are divisible by 8. Then the entire number is divisible by 8. Then the sum of the digits, if you add the digits, and if it's a multiple of 9, then the number can be divided by 9, same as 3. Okay, if the last digit is 0, it can be divided by 10, because then you can just cancel out the zeros, right? So these are some shortcuts, good to remember. This is how I do when I look at a number. You know, it's ending with a 5, or if it's ending with a 0, I immediately know they can be divided by 5. If it's ending with an even number, I immediately know it can be divided by 2. Okay, and then there are other shortcuts, like if you can add those numbers, and if it's a multiple of multiple of 3 or 9, it can be divided by them. And then yeah, so like these are the shortcuts that you can remember. Okay, the other thing I wanted to show you was, let me look at factorization. So if you look at like factoring polynomial expression, so you have x squared, you have something here, an expression here, and how you can write that expression is x plus a times x plus b, right? So this is nothing but a squared plus 2ab. I don't know if you guys know that yet, but a squared plus 2ab plus b squared, you can write that as a plus b the whole squared. Okay, so how they get that is you take a plus b and then you multiply it with another a plus b. So first you take the first term and multiply it with both the terms. So a times a is a squared, a times b is ab. Then you take b and you multiply it with both the terms. B times a is again ab or ba. plus b squared. So you're left with a squared plus 2ab plus b squared. So that's how they get that, get this equation. Okay, so you have similar expressions here. See, here you have x squared plus 2ax plus a squared. So basically, remember our, I don't know where I wrote that. Yeah, yep. Okay, so this one, if you divide the middle expression by 2, you get ab. Okay, so then I can write that as a plus b times a plus b. Okay, so that's essentially what they've done here. So if you divide 2a by 2, you get a, and then so if you, for this one, it would be x plus a times x plus a, because here your a and b are a and x here. Okay, so it's the same exact thing. So we'll understand as we keep going, but I just wanted to mention that to you all. So if you see here, you have the first problem which says x squared plus 2x plus 1. Okay, so here if you see, if you divide your middle term, you get x. So you have x and 1 as your two factors here. Okay, so I can write this as x squared plus 2x plus 1 squared, right? So since my middle two factors are my a and b are x and 1, I can write this expression as x plus 1 times x plus 1. Okay, so I can check now. X times x is x squared, 1 times x is x. Okay, then x, 1 times, now I'm done using this to multiply this, and I'm going to use this to multiply this term, these two terms. So 1 times x is x again, and 1 times 1 is 1 squared or 1. So I have x squared plus 2x plus 1 squared, which are 1. Okay, so is it the same as the equation they've given us? So our factors are x plus 1 times x plus 1, or you can write that as x plus 1 the whole squared. Okay, x plus 1 times x plus 1. Okay, I hope that makes sense. Now let's look at the next one. Okay, the next one says x squared plus 4x plus 4. Okay, so here look at my middle, divide this by 2, you get 2x. So what are your a and b? Your a and b are 2 and x. Okay, so I can write this as 2 plus x and 2 plus x, because here I have 2 squared here, right, which is 4. This is 2 squared, and this is x squared. So x squared plus 4x plus 2 squared is my equation. So let's see if we get that. So 2 times 2 is 4, plus 2 times x is 2x, plus now we move, so we're done with this. Now we're going to multiply this with both these terms. X times 2 is 2x, x times x is x squared. So do I have 4 plus 4x plus x squared? 4 plus 4x plus x squared, right? So I can confidently say that these two are my terms, or I can say 2 plus x the whole squared, or you can also say that as x plus 2 the whole squared. Okay, it'll give you the same result. It'll just give you x squared first, and then 4x, and then 4. Okay, I hope that makes sense. Moving on. Now we have x squared plus 6x plus 9. Okay, let me divide this by 2. What do I get? 3x. So my a and b here are 3 and x. So let me write that as 3 plus x, or x plus 3 times x plus 3. Okay, so that would be x plus 3 the whole squared. Okay, similarly, now I have x squared plus 8x plus 4 squared. So if I divide this by 2, I get 4x. So my terms are x plus 4 and x plus 4, or x plus 4 the whole squared. Okay, and you can check, you can multiply x with x plus 4 first, and then 4 with x plus 4, and check if you're getting this. Okay, this is x plus 4 the whole squared. Okay, now I have 10x. So if I divide this by 2, I'll get 5 and x. So my two terms are x and 5, because I have x squared and 5 squared here. So x plus 5 the whole squared. Okay, so and then the next one is x squared and 6 squared here. And so if I divide this by 2, I get 6 here. So I can safely say 6 and x are my a and b. So my a is x and my b is 6. So x plus 6 the whole squared. Okay.